Okay, let's start. Hi everyone, with you Elena Litvinova, and I'm software engineer, and today I'm going to show you how to use bubble sort algorithm and how it works, and discuss everything around it. Yeah, I slightly worry. This is my first video on my English YouTube channel. I also have a Russian YouTube channel, and if you want, you can subscribe. And before we start our video, don't forget to subscribe on this channel and press bell icon not missing next video. Yes, I'm going to create a lot. Yes, let's start. Open any editor which you have. I have a VS Code, and open a folder where we will create our bubble sort. We need to test it, but anyway, if you can't, we just looked in the algorithm really good way. I hope. And okay, documents, bubble sort. Well, and here I just create index.js file. What is bubble sort? Bubble sort, it is an algorithm which help you to sort data. Usually we have an array with numbers. Yes, and I believe it's usually with bubble sort we can sort numbers, or I don't know. I think, yeah, we could sort maybe everything what we want, but usually it is numbers. Yeah. Okay, let's create an array. I will use a JavaScript language because I am a JavaScript programmer mostly, and JavaScript language. Okay, create an array. Any numbers here, 7, I don't know, 10, already sorted, yeah? Okay, 0, -1, -11, 8, 9. For example, array like this. And we need to create a function which we'll call bubble sort. You can call it another way, but usually it's better to give names your functions which is quite close with reality, you know. And we have an array. We have to push here any array, and this function, if we call it console.log, if we call this function with this array, we actually can even do another way slightly. For example, put it like that. Remove this, and it have to return us sorted array. It means for this example it have to be -11, -1, 0, 3, 5, 7, 8, 9. I think, yeah, something like that. And we have to write this function. There are a lot of different algorithms how it's possible to do with different time complexity and space complexity. And we will try, yeah, bubble sort. How it works, bubble sort. For example, we have an array. And firstly, what we need to do, go through this array. I just create a comment, and we go for each number, through each number, and we compare numbers which is close. For example, firstly, we pick up 3, compare with 5, which one is greater. And for example, we see 3 and 5. Okay, 5 is greater, left everything like it was. After it, we compare next two elements, 5 and 7. 7 is greater. Okay, touch nothing. After it, we go compare these two numbers, and we see that 0 is less. And because of it, we change their place. After it, we go next 7 and -1, and we see that -1 is smaller than 7, And because of it, we put like that, minus 1, 7, change places, yes? After it, we have minus 11, again compare these numbers, and we see that minus 11 is smaller, we change their places. After it, we see 8, and currently everything is okay. 8 is greater than 7, and after it 9, 9 is greater than 8. It is the first iteration. We could call it 0 iteration. Okay, it is 0 iteration. After it, we go to first iteration. Why I call it 0? Because each array numbering started from 0. 1, 2, 3, 4, 5, 6, and 1, 2, 0, 1, 2, 3, 4, 5, 6, 7. 7. We have 8 numbers. Length is equal 8. Well, go next. When you have a bubble sort, you have 2 loops. One is inside of first one. We have to go through the array, and again inside of it we go through this array again and again for each iteration first cycle, and just compare each number and swap if it need. Swap what is greater or what is smaller. Yeah, how we do it now in the previous iteration. Okay, now we have the array on the next iteration like that. I'm not going to put here commas, just understand it. This is array. Okay, we compare again. 3, 5. 5 is greater, not touch. After it 0, 0 is smaller, 0, 5. After it minus 1, 5. After it minus 11, 5. After it we see 7, 8, 9. Okay, it's cool. Okay, and after it we have next iteration. Again, we have array already like that. Okay, and what we have? 3, 0. 0 is less, 3 is here. Minus 1 is less, it means it put here. Minus 11 is less, we put it here. And after it 5, 7, 8, 9. Everything compare, of course, again, but we see that we could change nothing, that left it as it was. Third iteration, and actually it's fourth iteration, yeah. We have an array like that already, and again compare. Minus 1 is less, minus 11 is less than 0, after 0, 3, 5, 7, 8, 9. Okay, third iteration was finished. 4. Okay, not third, it's fourth iteration, sorry. Okay, after it we have an array like that. Okay, and again we just see that minus 11 is less, minus 1, and other things we doesn't change. If there is no one optimization, we will go also on I believe 1, 2, 3 on 6 iteration. Yes, 6, after it 7, and yeah, okay, 0, 1, 2, 3, 4, 5, 6. Actually it will minus 1. Our loop will be before 6 because we compare two numbers and we don't need to go to the last one just because with what we will compare, yeah. And because of it we will have just 6 iteration, and yeah, and we will compare again and again 2 times, and we see now it doesn't need, but it could be need if, for example, we have something super small on the last position. It need to check, just to try homework. Yeah, okay, let's now create an algorithm how everything works. Okay, firstly what we can do, we can subscribe length and create 2 loops. First loop, let I is equal 0, I less than len minus 1, because we don't need to go deeper, swap deeper, yes, and I plus plus. Inside of it we have another loop g, which also always starts from 0 position, I mean from first element, and also g less than len minus 1, j plus plus. Okay, and here we need to make swaps. How it usually do, and after it we just return array. How you see, the array will be mutated. I mean, if you pass any array there, it will change. It will be changed. Okay, firstly we need to check if r of j more than r j plus 1. It means, for example, we have j, I don't know, for example, 0, yes, and j plus 1, it is next element. And if our previous element is greater than a next one, what we need to do? To swap, yes. Okay, and let's do it. We just need to save saved item here and put in this element this one, because yeah, we changed, and after it we just put in this element on this place saved item, and that's it. And here we will have something like that. We have 0 iteration, go through all of items here, compare them, change their places, and again we go to next iteration, again go through all of this, the whole array, compare everything, and yeah. Okay, let's start and check, because I'm not sure that it works. Okay. Okay, looks like it works. Yeah. Elena starts this program and looks like that everything have been sorted. 0, 3, 5, 7, 8, 9. I also want to check iterations. Let's console.log. Let's do console.log. We put I, it's our step, yeah, and an array. What we have now? Okay, and how you see, we have 6 iteration. Actually, I just made console.log here. I can remove console log here, just not confuse anyone. And again, what we have? 0, 1, 6 iteration. We could check how we calculate it manually. Okay, 0 iteration, 3, 5, 0, minus 1, minus 11, 7, 8, 9, right? After it's 3, 0, minus 1, minus 11, 5, 7, 8, 9, right? After it's 0, minus 1, minus 11, 3, 5, 7, 8, 9, good, good, good. Minus 1, minus 11, 0, blah, 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 right? Minus 11, minus 1, 0. Okay, here is everything already sorted, and because it is repeated. How we could see, we calculated everything right. When we try to study sort algorithms, it's really good to understand how every single number changed. I remember when I studied different sort algorithms, I studied at university, and it was really difficult for me to understand everything. And I just tried to use paper and just to write every single number there. And yeah, just compare. And I remember when we pass, I mean, it wasn't exam, it was just test. And the teacher asked everything about each sort. It was not only bubble sort, it was quick sort as well, shell sort, and others. And she asked to show how every single number changed. And I I remember that I was sitting close to her and just write on a paper a lot of everything. Okay, let's look on this algorithm again. Could we slightly optimize it? Because how we can see, we have some iteration where the array already sorted, yes? And why we need it, yeah? Why we need to go again and again through this array if we not swap anything? Because of it, or for example, if we call this function with already sorted array, we don't need sort anything, and I mean spend time complexity, yes. Because of it, let's add additional variable, which we'll call swapped, and by default it false. And if we go into this condition, we say swapped true, and after it, if swapped, I mean no swapped, it's still false, we break. But because we go through all this array again and again, we should to put this variable here. On each iteration we should to say false, yes, and because of that we will not have some iteration at the end. Okay, let's try. I stopped to console.log. Let's again console.log, but not in J loop. I want somewhere here. Array, okay, and hoop, and here let's put I, how many iterations we will have. And how you can see, we have just 5 iterations, because yeah, it's first one, after it we has no one swap, and yeah, we just have 5 iterations, not 6. It is a small optimization. For example, if for example we have already sorted array, we can try. Let's try just one iteration. Yeah, we not spend anything from computer. Okay, and this is bubble sort. What also need to say about this sort? It is a quite difficult algorithm for programs. Because if you work, for example, with a huge amount of data, I mean not 7 numbers in your array. I mean, if you, for example, want to work with a huge amount of data, I mean, don't know, 1 million, for example, yeah? For this array, n equal time. It means you pick up first number and go through whole array again, through the whole array. You pick up next number, go again through whole array. And it is time complexity or quadratic n, and it is quite difficult time because how we know it's grow extremely fast, yeah. And because of it, there are a lot of different algorithms, such as, for example, quicksort. In the best case, it could have a time complexity, I don't remember exactly, need to repeat, and multiply log n. And it is quite much more better. Yeah, but it is, how I remember, it is the best case. But anyway, this algorithm is really quite good. It is really simple if you want to use it for not a huge amount of data. And I hope that you understand how everything works. If you are not and you have any question, just write a comment, press like button, bell icon and everything. And subscribe, of course, on my channel. I'm going to create here a lot of different videos. Of course, not only about algorithms. It is my first video, and I just tried to find something which is quite simple and help me, I don't know, go into YouTube. With you were Elena, with you was Elena Litvinova. I hope you enjoyed this video and see you next time. Bye bye.